So I chose to start the video today with the human cannonball example. And so today we're going to talk about quadratics and projectiles. So three things to consider are the three forces that affect a projectile's height over the ground. So here you're going to take some notes, and the notes that you're going to take, you're going to fill in are in red. Gravity keeps you on the ground and causes objects to fall. Velocity is the outside force applied, and initial height is the starting height. So you can pause the video here and write down those definitions. The next thing, step 2, is we're going to talk about the formula for height over an object. And I would maybe highlight that. So the formula for the height of an object over time. And what those things stand for here is T equals time, VO is the initial velocity, and S is the initial height. And you'll see that in the second example here. Okay. In A, it talks about Galileo's formula, and we just talked about that in our notes in 9.2. We talked about that. And the only difference here is we have a little negative sign, and that must mean that our graph would be going downwards. In general English measures, just some things for you to consider. We would say that you're falling at about 16 feet per second, and so that's the English measure. And the metric measure, you're falling at about 4.9 meters per second, and you might need that for some of your formulas. All right. So in this formula, we have T, and that equals time. VO is your initial velocity. And the S is your initial height. And that is also highlighted up here, in case you want to see that again. So let's turn the page now and move into example 1. It says a rocket's height is given by the equation h equals negative 22.2 t squared plus 133 t. So here it says let's graph that. So on the bottom of the page we actually have a graph, and we're going to use that equation. So I'm going to rewrite that equation right on top of here. H equals negative 22.2 t squared plus 133 t. And we're going to fill that in for each of the t values here. So I'm going to take some time now to pause the video and work through those, and then you can check your answers when you unpause the video. Okay, so as you can see, I filled out the table for all the given values, including the 6. So here, what I did was I placed the t value into the equation and solved for h. Now the next thing I want to do is go over to my graph here, and I want to graph these. And I'll tell you now that the bottom is, I shouldn't say the bottom, the x-axis is seconds, and the y-axis is feet. So the y-axis would be feet. The best thing to do, I think, is to put a 1 every 2 marks. So here on the third one I put a 1, and then a 2, 3. Going up the side, I would go up by 10s and maybe only label at the every 20. So I'm going to pause again and fill out my graph. So as you can see, I filled out the rest of the graph and I plotted the points in red. So my parabola will look something like this once I connect those. All right, so once I've done that, I'm going to go up and I'm going to answer some of the questions. I can answer the questions, one by using the graph. So I did that. And now, how high is the rocket at 2 seconds? So I can look at my table, and it shows here at 2 seconds, it's 177 feet. And if I want to check that, I can come up here and say, yep, that's at about 177 feet. So let's say, how high is it? 177 feet. How high is the rocket at 3 seconds? I've got that one right underneath it. It's at about 199. I look at my graph. Is that correct with my graph? Yep, it's correct. So at 3 seconds, my rocket is 199 feet. From the graph, when does the rocket reach a height of 50 feet? So let's look at the graph. So we're looking at this graph, and I'm looking at 50 feet. It's right here. It reaches there at between 0 and 1 second, and then it also reaches there between 5 and 6 seconds. So between 0 and 1 second, and again between 5 and 6 seconds. E says about how many seconds will it take for the rocket to reach its maximum height. So its maximum height is here at 199, and we know that that is at about 3 seconds. So I can put that there, about 3 seconds. Remember when you're doing your practice tests and your homework that you need to label all your answers. All right, let's move to the next page. So using the formula h equals blank t squared plus the velocity of time plus s, we're going to look at that equation for this example. So an object is dropped from an initial height of 40 meters. Write a formula describing the height of the volume in meters after t seconds. So if we go back to that very first page, we learned that it is roughly about 4.9 meters per second. So I'm going to plug that into my, that's a given. That's every time. That would be how many meters something falls. I don't know the seconds yet. I have no velocity, and my meters would be here. So now we can start filling them in. So about how high after 2 seconds? 2 seconds is going to be your time. So here I have h equals negative 4.9. Put the 2 in for t squared plus 0 times 2 plus, now I'm going to add in this 40 meters for the initial height. So looking at this, this is going to end up being 0, this is going to be 40, and I need to figure this out. This is going to be 4 times negative 0.4. So if you work that out, you're going to get, after 20 seconds, your object will have fallen 20.4 meters. This last question on this one says, after how many seconds does the object hit the ground? Okay, so when the object hits the ground, it has a height of 0. Use the same formula, negative 4.9 t2. Again, it has no velocity, so I'm going to take that part out, and it starts at initial height of 40. Put the decimal in there. Now I'm going to solve it like the equations I was doing in class today or yesterday, depending on when you had lesson 9.1 and 9.2. So two-step algebraic equation. going to subtract 40 from both sides. If you need to draw your train tracks, you can. So I have negative 40 equals negative 4.9 t squared. I'm going to give you a couple seconds to figure that one out, so you can pause the video and try to work the rest of the problem on your own. Okay, so now you can check your answer with mine. If you look at this, to undo the square root, you get a plus or minus. So do the square root and you get about 2.9 seconds or a negative 2.9 seconds. Now, in the real world, we don't have a negative 2.9 seconds, so that would not be an answer, and it would just be t is about 2.9 seconds. Okay, so looking at this example, we are looking at the, using our equation, we're looking at the object that was thrown upwards at a velocity of 20 meters per second. So it says, what is the initial height of the ball? So we go to our graph and we look at, where does it start? Well, it starts at 0 meters because we're talking about height. And it says, at what time will the ball hit its maximum height? So now we're looking at time. So when I look at that, I want to look at maximum height is right here, but my time is at 2 seconds. Part C says, how long is the ball in the air? Well, from here to here, it's in the air about 4 seconds. So that's when I put those squiggly lines there to indicate about. And then at what times will the ball reach a height of 10 meters? So that's when I'm going to go grab my gray, and I'm at 10 meters. Right here it hits 10 meters, and again right here it hits 10 meters. So I would say between 0 and 1 second, and between 3 and 4 seconds. All right, we're on to our last example, and that's example 4. A ball is thrown from an initial height of 10 feet. So here's the important things. Initial height is 10 feet, and the initial velocity is 64 feet per second. So it says write an equation describing the height in feet of the ball after t seconds. So here I have h equals negative 16t squared, and the negative 16 is the amount of feet the ball will drop per second, and we got that from our notes. And then we're going to write down the initial velocity of 64 feet per second, and then plus the initial height of 10 feet. So that's our equation. Now we can say, how high will the ball be after 3 seconds? So that's when I'm going to plug 3 seconds in for t. So I'm going to pause the video and show you how that works. So here's the equation with 3 substituted in for each of the t's. So when I evaluate this, it means I have a negative 144 plus 192 plus 10. And that equals about, or not about, but 58 feet. So that would be the height after 3 seconds. So what's the maximum height of the ball? Is a question we are actually going to skip. So we are finished with our notes for today, and you can grab your homework and get started on that. All answers for homework are posted on Moodle. Thanks for watching.